Alright, let's do this. This was a request. Some people who had quiz version B wanted me to do, I think it's number 7. Oh, obviously it's number 9 from the very last page of the quiz. So I'm going to take a stab at it real quick. Number 9. So this one says graph the velocity versus time graph for the following displacement versus time graph. Okay, let's take a look. Now I'll show you guys some quick shortcuts. When I'm looking at this, in fact I'm going to zoom in a little bit. Let me see if I can. Alright, let's take a look. I gotta get a close view. If you take a look here, guys, and you'll notice this. The very start, you go down 2 and over 1. If you're going down 2 and over 1, that means that you have a slope of -2. And to be honest, we know the slope has a unit. It's going to be meters per second. Okay, let's zoom back out. So, well, when does this slope take place? Well, this slope happens here to here, or be more correct, from 0 seconds to 4 seconds. So when I come over here and draw it, I'm going to use my red line right here. From 0 to 4, I have a slope of -2, or a value of -2 meters per second. And there you go. There's our first entry. Alright? Now, I'm going to skip over this section for the very, very end, because this is going to be the most math-intensive section. I can look right here at time 8 to time 10, and you'll see when I look at this point and this point right here that we have a slope of 0. And once again, slope of 0, velocity of 0. So from time 8 to 10, you should have a value of 0. Alright, now, last but not least, let's take a look from time 10 to 12. As you can see, if I zoom in on this, we're going to go, you go up 1 over 1, giving you a slope of +1 meter per second. So we zoom back out, up 1 over 1, I'm going to have these last ones, this value. Okay, so let us begin our final part. This is the most annoying part. So, as we look at this very first D versus T graph, we see, once again, if we remember what Mr. Lee told us the day of the quiz, your V, up, Control Z, that's not what I want. I want my pencil up. Let's go with blue. V, this was given you on the day of the quiz, VI equals 0 meters per second. Now what we can look at is here. This curve happens from 4 to 8. So that means our time, the total time interval of this particular curve is 4 seconds. It starts at time 4 and goes to 8. The difference makes that time a total of 4 seconds. Now let's look at this. You start at a displacement of 4 and you go up to 12. So your displacement for this is going to be D equals 8 meters. Now how did I get that once again? 4 and 12, 8 meters. The difference between them. Okay, so let's get calculating. Well, what do we need to find? Well, the first thing I'd like to find is the acceleration. Okay, well, what is the acceleration? Well, acceleration can be found using this formula. D equals VIT plus 1/2 AT squared. Now the first thing you should realize is that our initial velocity is 0. This whole term right here is going to cancel out. It's going to explode into a 0. So you're left with D equals 0 plus, but 0 plus anything it doesn't matter. I can just negate it. 1/2 AT squared. Okay, so we've got this one. Now we can do one of two things. We could either manipulate our formula to solve for A, or we just plug in. And I'm going to manipulate. You know, I'm in the manipulating mood. Let's multiply both sides by 2. Multiplying both sides by 2, you'll see that this now crosses out, cancels out. 2 times 1/2 gives you 1, and leaves you with 2D equals AT squared. Okay? So now, the next thing I would like to do besides change colors. I'm going to multiply or divide both sides by t squared. And you should see we'll get a final formula of 2d over t squared equals a. Alright, and we can just plug in now. 2 times 8 is going to be 16 meters divided by my time 4 squared is 16. Oh, I'm moving things around. 16 seconds. Oh, let me erase that. 16 seconds, and I about made a mistake, squared. So when we divide these, you should get an A equal to 1 meter per second squared. Okay. Alright, we've got that first part done. Let's now, I'm going to give myself some more room. Oh, not what I wanted. I'm just going to erase all this though. This is taking a little longer than I thought. Sorry guys. So now, once we've got our acceleration, we've got two different ways we can go from here. Both of them are correct. Both of them are pretty easy. One is to use the slope formula for this next problem. The other is to use a physics formula. I will go to the physics formula side. Mr. Lee, I believe, originally showed you guys how to use the slope formula. I'll go physics. So, nothing against Mr. Lee. What we need to find, guys, is your VF. So we have our A now. We have our VI, we have our T, we have our D. We could easily find a formula. VF equals VI plus AT has this guy, this guy, this guy, and this guy on. Okay. So all we have to do is just plug in, you know, nothing too difficult. VI is 0, A is 1, T is 4, so you're left with a VF equal to 4 meters per second. Okay. Well, let's take a look. Now you might be saying, Mr. Shaw, what does all this mean? Well, what this means is this. We have a VI of 0 and a VF of 4. VI is 0. So where's VI 0? And remember, this is not at time 0. It's going to be at time 4 is when this starts. So you're going to start here, and we end up here at time 8. Oh, don't do that. Okay. So our VI is 0 though, and our VF is actually going to be 4. So when I draw this now, it's going to start right here, which I will delete. And it's going to go right here. It has a slope of 1, guys. Once again, look. The initial velocity is 0. That's what we saw. That's what we know. Our final velocity is 4. That's what we know. And we know that our acceleration, or our slope, is 1. And that looks good too. So everything looks fantastic. And if you wanted to, you can get down and draw your little dotted lines now. And remember, Mr. Lee asked you to label your points. So if you want to label your points, you can do that too. Alright. I will not label my points. You guys can have a good one. Have fun with that. Talk to you later.